So what does coiling a rope and finding the greatest common factor have in common? What do, not does. Well, my dad, I grew up on a ranch in Montana, and my dad once taught me that when you coil a rope, you make the coils work for you, okay? Don't just sit there and try to do that weird thing where it coils all funky on you. And if you ever coiled a garden hose or an extension cord, you know exactly what I'm talking about. It's something similar with ropes. Although if you're roping a cow, I think there might be a little more to it than that, because you want to have the right play, because you have to be able to get that rope out quick. But the point is, what does coiling a rope have to do with factoring? Well, like coiling a rope, you make it work for you, and you try to not make it too hard on yourself. Same thing with factoring. Factor out the greatest common factor first, and then the rest of the factoring is going to come out a little easier. If you don't factor out the greatest common factor, then factoring could get pretty hard. So I've got 1, 2, 3, 4, 5 problems here for you to try out, okay? Go ahead and hit pause and see if you can get these guys by factoring out the greatest common factor. Go ahead. Okay, if you didn't hit pause, then you probably just had a weird, awkward pause while I kept my mouth shut and waited for you to pause. So let's see how you did. 9x squared plus 3. Did you factor out a 3 as your greatest common factor, leaving you with 9x squared? If you did, then you're wrong. You know, I should have used red, because red's, I could say red, not good in this case. Yeah, sometimes people say, oh yeah, factor the 3 out, then nothing's left. Wrong. There's always something left, okay? In this case, it's a 1. If you multiply it back through, 3 times 9, whoa, that's wrong too. Just caught that. Sorry about that. There. In fact, that's a good way to check your answer. Factoring is basically the same thing as division, I like to say. It's the opposite of multiplication. See, if you go backwards, if we multiply the 3 through, 3 times 3x squared, you get 9x squared. And I'm going to make my little mistake that I just made work for me here. I had a 9x squared there a second ago, and I knew I got it wrong. I'm like, ah, that's embarrassing. So yeah, I'm covering my back here. I also had that plus 1. 3 times 1 is that 3. All right, let's take a look at the second one. This one's a little different. So let's see, 20, -4, and 12. Greatest common factor among the coefficients would be a 4, right? So I'll pull that 4 out. Now let's look at the variables. Y squared, y to the third, y to the fourth. The smallest of those guys would be the y squared, right? So I'm going to factor out a y squared. All right. So another way of looking at this would be to do this. 20y squared divided by 4y squared is 5. -4y cubed divided by 4y squared is a -y. And finally, 12y to the fourth divided by 4y squared is 3y squared. And that is the answer for that factoring. Now this guy, let's see what happens here. Kind of weird, huh? Yeah, that guy's prime. Nothing comes out. All right. 6a to the fourth b squared minus 3a squared b squared. Let's see, the coefficients, we're going to have a 3, an a squared, and a b squared. Let's see what's left. 2a squared. I'm going to go a little faster now. Minus 1, right? Everything factored out, don't say everything. There's always a 1 left. If everything seems like it came out, there's always 1 left over. All right, now the last one. My leading coefficient is a negative, so I'm going to factor out something negative. A -2, in fact. So I'll factor out a -2. I'll factor out a y. They all have a y in common. They do not all have an x in common. See, the last term does not have an x. All right, let's see what's left over. -2x squared y divided by the -2y gives me a positive x squared. Negative 4xy divided by negative 2y gives me a positive 2x. Negative 10y divided by negative 2y is a negative 5. And that is as far as that one goes. Down the line, we're going to see this trinomial that you get there possibly factor some more.